Okay, so we're live. Welcome to this session. The session will be about the new Ehcache release, which is Ehcache 3. I intend to do just a live coding exercise showing you the way you can work with Ehcache in your applications. And for that, instead of trying to create a fake application or do something, what I did is I picked up the pet clinic application from the Spring framework. And what we're going to look at for the moment is just the fact that you can search for pet owners by their last name. And when you find an owner, what we see, I've tailored the logs a little bit, is that you see SQL queries, meaning we went to the database. And so the whole idea is that we're going to install a cache there in order to have less load on the database. I probably forgot to introduce myself. So Louis Jacomet, I'm one of the Ehcache developers. Jacomet on Twitter, and you're welcome to ask questions either during the talk or at the end. Just come talk to me. So the pet clinic application is a pretty simple, basic application. That's why I was using it. It has in its service layer the clinic service implementation, and what we're going to look at is this method where you can find owners by last name, and as you see, it takes a string as a parameter, and it returns a collection of owner. So the idea is to cache that. So the way we're going to do that is by having an Ehcache file. Looks like I forgot to remove stuff. So I create an Ehcache XML. We're going to start with the XML configuration. In Ehcache 2x, while there was an XSD to help you to help IDEs help you fill in the configuration files, in Ehcache 3, we actually will validate the file when loading it. So let's take that owner search, and we're going to start with the simplest cache we can have, which is a heap cache with 100 entries. And that's it. I've defined a cache. So now what I need to do is I need to use that cache inside the application. And the way I'm going to do that is I'm simply going to add a bean, which is going to return a cache manager. And that cache manager, I'm going to load it from the XML configuration. There is probably a Spring way of doing that, but I'm going to do it the classical way, which is cache ehcache.xml. This returns me this gives me an XML configuration. And we have a Fluent API for building cache manager and cache configurations. So what I'm going to do here is use the cache manager builder, which is going to give me just a method new cache manager, and I can pass it my configuration. And with that, I have an available cache manager. Although, one thing that did not exist in Ehcache 2x was a strict lifecycle, and we've implemented that in Ehcache 3 because while it's less necessary when you're talking just about on-heap caches, as soon as you think about disk-based cache or even clustered cache, it makes sense to be able to control the lifecycle. So what we need to do here is initialize the cache manager. No, that's not what initialize the cache manager, and then we can return it. And that's it. I've got an initialized cache manager, which of course I need to use in my service. So the way I'm going to do that is I'm going to use what Spring is good at, which means injection. Just declare that I need a cache manager on this auto-wired constructor. And the cache manager, I'm going to use it directly to get the owner's search. Which needs, as we've seen the signature of the method, a string.class and a collection.class parameters, because this is the way I can make sure my caches are strong typed, which is a feature of Ehcache 3. And so I'm going to make a field of that owner search cache, and that's it, I have it. And of course, it means I need to go back to my XML, because the simplest cache, when it's typed, still needs to know the type it contains. So it's a string, and the value type is a collection. That's it. I can go back to. So now that I have my owner's search cache, I just need to do what's necessary in this method in order to use that cache. So from the cache, the first thing I want to do is check if it has any content for the last name I'm getting, because if it has content, I don't need to go to the database. So if owners different than null, I can just return that, because that's my cached result. If that's not the case, well, what I need to do is I need to properly initialize owner with the value coming from the database. I can return that, but of course, in order to benefit from my cache, I need to put this new entry in the cache so that any subsequent invocation will be able to return from the cache the result. With that, we should have what we need. So let's go here, stop the application that was not cache enabled, wait for the pet clinic application to start. Here you see that Ehcache by default when starting will tell you where it loaded the XML configuration from, which I think is a useful information if you're looking to verify your config, and also that there was a cache owner search created. So with that, if I go back to find owners and search for my Davis owners, well, obviously my cache is cold, so I'm hitting the database. If I clear that screen, search again, and find the owners, I still get an answer, but I don't see any SQL statements. Yay, caching works. How surprising is that? No, so you've seen the way this works. What we can do is have a look a little bit more at the options at the level of the XML configuration. So first of all, while I've specified the key and the value type, and I've specified that I want 100 heap entries, what I didn't say was what should happen with the freshness of the data. What's the expiry I want? And so for that, I just need to add the expiry tag. I have a number of predefined classes of expiry. I'm going to use TTL, which stands for time to live. So the moment an entry makes it into the cache, the counter starts. And I'm going to give it a default of 60, which actually is seconds, because that's the default. But you see that you can here use a number of options from nanos to days, depending on what you want. So we set seconds. So that gives me, for example, a TTL of 60 seconds. But I could also use a TTI, which is a time to idle, and I could also use my own expiry class, which is a contract that you can implement. If we look at the expiry class of Ehcache, a contract that you can implement, and as you see, it has 3 methods. Get expiry for creation, which will be invoked when a mapping makes it into the cache the first time. Get expiry for access, which will be invoked each time you touch a mapping by doing a get on it. Get expiry for update, which will be invoked when you actually replace a mapping. And as you can see, while get expiry for creation hands you the key and the value, which allows you to have smart expiry strategies if you need them, you see that as soon as we're talking about an old value, which is the case in get expiry for access and get expiry for update, they're wrapped in a value supplier, because there is a cost associated to that. If you do on-heap caching, the cost is 0. But if you think about disk-based or off-heap or clustered, there is a cost in retrieving the old value, because otherwise we may not need to go get it. So that's the reason you've got these slightly evolved wrappers around the type. So one other thing that we introduced with Ehcache 3 is the concept of cache template. Ehcache 2 had a concept of a default cache. And when you define the default cache, what happened is that if you were creating caches programmatically without specifying configuration, they would inherit from the default configuration, which is good and bad, because it gives you some flexibility, but we believe the flexibility was not enough. So what we ended up doing is having a first-class citizen, the concept of a cache template. And so, for example, here, I'm going to say this is my default template. And no need to be very creative. We can just say it's an expiry, TTL, the same 60, and it's heap 100 entries. And that means what I can do is I can here say to my owner's cache that he should use the default template. And if I do that, then I can simply get rid of that. And so this is very useful because if you end up having to define a lot of caches which may have as their sole difference the key type and the value type, you can actually extract all of that in a template and just have very, very thin cache declarations next to that. Templates are not stackable, so a template cannot inherit a template, and a cache can only inherit a single template. But we also believe that's probably enough for the normal needs. So I've shown things using XML, but you can, of course, decide to go fully programmatic. So the way you would do that is, well, start over here. So what we're doing here now is we create a cache manager builder, which is the start of our Fluent API. And this will provide us all we need, so we know that at the end, that's what we're going to return, because it will end up building not only a cache manager, but also I can specify immediately that I want the cache manager to be already initialized. So my cache manager builder, the first thing I'm going to do is I'm going to configure, like in XML, the cache I want. So it's going to be, again, owner search. And here, I'm going to have to go get a cache configuration builder, which I'm going to statically import. No, that's not what I wanted to do. I'm going to get a cache configuration builder, which has a number of mandatory attributes. And these are the attributes you need to specify so that we can help you when you use the different builder methods, getting the right types in place. So what I need is the key type, the value type, just as we discussed, and then, import that. And then my heap resource with, again, my 100 entries. And with that, I can build my cache manager saying that I want it to be initialized. And that's it. I have the equivalent of the first version of the XML file. Of course, you can do the exact same as with the XML. You can specify expiry. You've got a time to live, expiration. We've got a duration class, which allows you to create durations, and you use, again, the whole logic is to have a Fluent API so that it reads cleanly when it's done. So now that I've done it that way, let's just show that it works. So we restart the application. I now have, again, my cache started, no longer an output saying that it's loading configuration because everything is programmatic. I can clear that log, go back to finding owners, again, find a Davis owners. First search hits the database, and if I search again, I no longer hit the database. Yay, it works. I know, caching is exciting, isn't it? Now, of course, that's really ugly. We're not really happy with that. I can't say I would recommend you to copy-paste that kind of pattern all over your application so that you've got cache aside. So we've got two paths here. Either we move with the Spring caching abstraction, which will give us annotation-based caching, or we go and we try to go with cache through, which is a pattern that you can use where the cache will be responsible for loading the data. And we should have time to do both. So I'm going to start with cache through, because it's a natural consequence of what we have here. But otherwise, after that, I'll show you when you leverage the Spring abstraction. So in order to do cache through, what we will need is we will need an owner search loader, which is an Ehcache component. Well, at least for the moment, it's just a class, but it's going to implement cache loader writer. And we know it's a string and a collection because these are the usual, the key and the value types we know from the beginning. And we have to implement a number of methods, only 6 methods. Damn, why is that? We just want to do loading. Well, the reason we do that, so first let me show you how you'll do the loading. So we want this to be a service, so that Spring properly initialize it. There, which means I want an auto-wired constructor. Which is going to take the owner repository and I'm going to create a field for it. That's it. And what I need to do is this method. I just need to return owner repository, find by last name, S, where S is that last name. That's it. This, once installed in the cache, will be the piece of code which will be invoked if the mapping is not mapped. So why the heck do I have all these methods, and especially the write methods? Well, it's because in Ehcache we believe that when you want to do just cache through, just read through, meaning you want your loader to only accept reads, what happens if someone writes to the cache? And what happens is really up to you. You have to make the decision. We can leave the code as is. It's going to throw an exception if anyone tries to put into the cache by themselves, outside of going through the loader. Technically, we would need to implement the load all method, but I'm going to skip that for now for the sake of conciseness. But the idea for the write method is that we don't want to support writes, no problem, we throw. Or you could say, oh no, it's fine. If you put stuff in the cache, it means it's derived data that does not really exist in the database. I'm fine with it. Well, up to you to have empty methods here. But at least it's your choice as an application developer to decide what should happen. So now that we've got this, we'll know we'll end up using the cache loader, so we can just do that. And all this code goes away. So the cache acts as a proxy on the database. Of course, for this to work, we need to finish wiring it. So I'm going to auto-wire the owner search loader. That's it. And here, I just need a loader writer, and that's it. Let's see if this works. Starting the app. My cache has been started, which means it got wired properly. Things seems to be good. So we go back to the application, again, searching for that Davis guys. Actually, there are 2 people with the last name Davis. And we see, of course, first time, we go to the database. Clear the log. Go back here. Yay, it works. And when you look at the service, it's kind of cleaner. You've moved, but of course, what you did was move the loading responsibility from your application to the cache itself by injecting it a loader writer. So now what we can do is do things slightly differently. Let's go back to the initial state. So we're going to revert all the changes we did. That leaves us with this 2 file. We'll keep the XML file. We can just delete that one. So of course, the goal was to show you the Ehcache APIs. But one thing that we value very much with Ehcache is integration with third-party frameworks. And the good news with Ehcache 3 is that it's fully Jcache compliant, Jcache being the GSR 107 Java X caching API, so the caching standard. And the good news is that Spring fully supports Jcache. So you can use the caching abstraction from Spring using Jcache compliant implementers. And so that's what we're going to do. We're going to leverage that in order to get immediate, for free, Ehcache 3 integration. So the one thing, though, is that Spring will use untyped caches. And if that's the case, you have to not type them or leave them to the default object. So the only thing I need to do in the configuration is just drop my cache, my key type, and my value type. Then what I want to do here is, so this is what we wanted to cache. I just want to add cacheable. The value of that annotation is the cache name. So that's it. And that's it. That's the cool benefit of doing cache aside, which is a pattern that suits itself very well to anything which is a wraparound logic. And so here, I mean, Spring will do it either by AOP or by proxying, but there is no clutter in your code. And on the pet clinic application, well, I just need one thing. It's to enable some of the Spring Boot magic. And then on my application of properties, well, I just need to do my Jcache config is cache ehcache.xml. The benefit of what I just did here is that technically I could move to my pom.xml and declare ehcache as a runtime dependency, which means your code has absolutely no compile time dependency on ehcache. It uses Spring. Spring builds on top of the Jcache abstraction and makes ehcache compliant. So let's have a check. There, so we see stuff has been properly loaded. I'm going to directly go to the owners. We see they've been loaded from the database. I can clear that. Do the same request again. And again, it works. Which, in a way, is much cleaner. And the good news is that you get all of this with minimal changes to the application, just enable caching, minimal changes to the services, so easy that we can do stuff like that. I'm now caching the veterinarians by just adding the annotation. Here in Ehcache, I've got two options. One would be to add another cache explicitly. But let's say that you're not exactly sure what kind of caches you're going to take. And so what you can do is you can configure the cache manager, and especially the GSR 107 support in it, so that you've got a number of defaults when Ehcache is used as GSR 107. And one of the default you can have is you can have a default template, which we're going to use default template. Sorry. And by doing that, a cache configured will use the default template. Damn, I think I'm going too fast, but let's see. Let's see what that gives. Yeah. I've been going too fast. What that does is not exactly what I said. What that does is it indicates that if you start creating caches from the GSR 107 API, which has an API to create cache, you can have this cache be extended with Ehcache configuration. Because, for example, one thing you cannot do with GSR 107 is size your caches. And so if you just use GSR 107 without anything, there is no way for you to limit the size of a cache. And so the way you can do that with Ehcache is you would use GSR 107 API. Let me quickly show you what that looks like. So again, I'm adding a bean. My bean is a cache manager, but I want the Spring Framework one. And what I do here is I do caching, which is the JSR 107 thing. I do the get caching provider, which uses the JDK service loader to load the default JSR 107 implementation that's found on the class path. If there are multiple, I can pick the one I want with the fully qualified class name. I can even pass it a class loader if I have specific requirements, such as an OSGI runtime. But otherwise, that gives me the provider. And once I have the provider, I can get the default cache manager, which will have no configuration. So that's just nothing. You can actually pass here a URI and a class loader and a property map. And then depending on the implementation, but you start entering implementation-specific world, it will do something. So in our case, what we want to do here is get resource, because we want to use that ehcache.xml to URI, and we can use the provider.get default class loader. I just need to throw an exception because this is there. And by doing that, I'm now loading my Ehcache XML file. And so if I start creating a mutable configuration, let's have object here, because Spring anyway uses untyped caches. So that's my configuration. And on my configuration, that's it. And then on the cache manager, I do a create cache. It was vets. And I give it the configuration. And now I can, I can return a Jcache cache manager from my cache manager. Oops. So I just need to wrap the Jcache cache manager into a Spring one, because the signatures are slightly different, so there is a bit of wrapping. If you think about it, it sounds weird, because you've got Spring having its own abstraction, wrapping the Java standard, which then wraps a provider. But since Spring had an existing abstraction, they would have to break everything in order to fully align on Jcache, and so it makes complete sense that they keep that and they just provide bridge. Of course, it means I no longer need that. And so what happens here is what I explained. I'm creating a cache that's specifying an empty configuration, because the configuration from JSR 107 is in any way slightly limited. And what's going to happen is that I'm going to end up loading from this file the default template. And since the vets cache doesn't exist, it will be created, and by default, we'll use the default template. Instead of using defaults, I could have been more specific. And I've done that like that. There. So that's equivalent, except that in this case, the default template will only apply if I create a vets cache. So now let's go here, and let's restart. So this time I see that my owner search cache has been created, but indeed my vets cache is created as well. So let's immediately try that. Find owners. Yay, I got SQL. Let's look at the veterinarians. Oh crap, I got an exception. Not serializable. Oh yes. A default from JSR 107. By default, that configuration indicates that the store by value is true. And the only way in Java to guarantee, in an abstract way, storing by value is to serialize. And so you need to make sure you store by value false. But since JSR 107 doesn't exist, it will be created, and by default, we'll use the default template. So So that's something, if you use GSR 107, that you need not to forget. And I see that I'm running out of time. Trust me, it would work. Thank you for your time, and I'll be around tomorrow morning if you've got questions, or maybe at the speakers' dinners. Thank you.